Folks, my name is Shiv Mehra. I'm glad to be here talking to all of you in person and online. Let's talk a bit about the NSP, the Nile Service Block. So as you know, we are now providing a service. Not only that, we are guaranteeing that service. So it all begins with the hardware. So to answer your question, we actually build our own access points, our own distribution switches, our own access switches, and our own sensors, all of these. Once they all interconnect, that forms the Nile Service Block, right? And we kind of own that in terms of managing it from the day-to-day operations perspective. If anything breaks, it's our headache. Software upgrades, patches, anything that needs to be done, it's on us, right? So that's basically the Nile.
Question: is it your own silicon as well, or merchant silicon?
No. We just any company how they would go and get it, from Asia. We work with them. We design it for our specs, right? Whatever we want, we will basically get it based on that. Yes.
Okay.
And is it built here? The switches, are they built here? Or are they built in Asia? Just curious.
They're built in Asia. Yes. So this system in NSP is a very deterministic system. What does that mean? So Suresh always gives this example of these trams that connect you from concourse A to concourse B in an airport, right? They've been there for ages, self-driving in a way, right? Autonomous in a way. Why? Very, very deterministic. They take a path from point A to point B, stop there, go to point C, and back. That's how we build the system. Why? Because in L3 architecture, we removed all the complexity. We don't need most of the L2 protocols. Only L3. We have kept the stuff that will help us, pass traffic through it, and services that is needed to bring the NSP up in an automated fashion. So we're not really configuring these boxes. No one is sitting in putting IPs on them, configuring the ports. None of that stuff happens. It's all automated with a beep and scan with a mobile app, right? And we can show you some of that stuff as part of the. Also, as Suresh mentioned, redundancy is built in everywhere. So multiple uplinks from the distribution switches to the customer's upstream router or firewall, multiple links from an A-access switch to a distribution switch. So one link cannot really bring this network down. The second thing we really focused on was security, right? As Suresh said, security is very, very important. So we have 3 layers of security. First layer is the box itself, right? It's completely locked down, so no one can really log into it. There's no console port. There's no console port attack acts, because if someone can get in, it can be hacked. So we made sure everything is completely locked. Secondly, we use MACsec between all our devices, so you cannot even snoop all that traffic, right? That's the infrastructure layer. The second is the access layer. Now today at the access layer, you can deploy the network, you can go and configure ports for .1x, you can go and configure ports for private VLAN, but it's not cookie cutter. You can't just use templates across all sites, because every site is a snowflake. Different types of devices, where do you connect? Very complex. So Nile, we decided that should not be the case. It should be built in from scratch. There's a very interesting post on LinkedIn by a gentleman called Mike Miller, and he's a pen tester, right? And he was assigned by this company to go and penetrate the network. He goes to a parking lot, takes about 5 boxes of donuts, and then walks, into the office. Someone opens the door, badges in him. He goes, sits into a cubicle, and next thing you know, he has access to the entire network, right? Now that would not happen with Nile. By default, all ports are blocked. So if Mike had to plug his laptop in, he has to be either authorized using .1x, or he has to do SSO, right? Or he has to be authorized using some sort of MAC authentication that is controlled by the admin, fingerprint-based or OUI-based. So those are things that we have put in place so that you just cannot get on the network by default. Also, we have host-based segmentation. So 2 devices on the same subnet can never talk to each other. It all goes through the firewall if it has to. So there's no way of malware to get propagated. The third layer of security is access. I'm on the network. What resources should I access? Today, if I can somehow get on the employee VLAN, then I have access to all the resources, just like Mike did. And all employees are not the same, right? Someone has more privileges, someone has less privileges. So you have to make sure that you don't take IP-based rules and then apply policies. Apply identity to it. What type of device do you have? Time of access, day of access. Try to club as much as possible so you can actually create a policy which is catered for just-in-time access, right? That's what a microsegmentation is. So that's the entire campus zero trust security. That's what our definition is. The third most important part, as we just spoke about, was the data collection, right? So we have deep instrumentation. All the metrics flow into the cloud, right? So anything to do with, our switches, our APs, we get no customer data is flowing in, but that's what's used to predict, anything that's happening, because we have to be proactive, not reactive. We cannot wait for that AP to go down, right? We have to know what was building up. So if a process was using too much CPU and it is at a stage where it should not be using that much CPU, something has to be done about it. You cannot wait for it to crash. We also extend that to our customers by providing our sensors. So we've got physical sensors, and you can see that that's up on the wall up there. And those physical sensors basically give them a view into the NSP itself. We've got sensors in the APs, a dedicated radio, and then we've also got virtual sensors inside of the switches, which can do transactions with the customer's network, like their radius, an actual radius transaction, an actual DHCP transaction, an actual DNS transaction. So they have that kind of visibility as well. Most importantly, this is done every single minute. So it's not like 5 minutes or 10 minutes. You can go minute by minute by minute, and you can see that data in our portal. And as we were talking earlier, today what customers do is they have a large campus, they'll go with a controller-based architecture. They have small remote sites, they just want to go with some cloud-based, cloud-managed infrastructure. That's what they would do. For Nile, we only have one single architecture, right? Because the way it comes up, the way it functions, the way it connects to the router is always going to be the same. There's no variation, just like that tram that goes from concourse A to B to C. Can that tram be 5 cars, 3 cars, 10 cars? The answer is yes. Same thing with us. Our NSB can scale down. So if you're on a large campus, we'll put 2 distribution switches, 4 uplinks to a router, and then every building would have rings of access switches, all dialing back into these in that core distribution switch. You come to a suite like this, really small. Our access switches act as those gateways, connect directly to the upstream router and firewall, just like what we have there. That's an NSB right there on the floor. We have APs, and you're good to go, right? So we can scale up or down very easily, and that's all managed from the cloud. So we don't have variations in the architecture. We do have variations in topology, right? You want to use fiber or Ethernet uplink, you could do that, all right?
So is all management done in band then? There's no way to, if you somehow get locked out of the device, is there no way to access it or?
So first thing is all the data is streamed out to the cloud. So usually before you get locked out, right, we would have like something crashes, right? So it's software, it can happen. If it crashes, we have all the data in the cloud, right? Worst comes to worst, we have a mobile app. We have some diagnostics that can be pulled from it using Bluetooth, and you would get that out. That's one thing that Suresh was mentioning. These systems are designed, hey, something is wrong, Bluetooth is on. So Bluetooth is not on 24/7. Every device has Bluetooth, but it's not on 24/7. Only during activation, beep and scan, I'm going to install the AP here, put it on a floor plan. That happens. That switch, the same thing. But if something stops working, then the Bluetooth would turn on.
So you mentioned firewall a couple of times. Is that a distributed firewall on all the devices, or is it centralized somehow?
So the policies are all centralized up in the cloud, and then it gets pushed down to the NSPs. Moser, I'm going to hand it over to you.
So I'm going to play a little bit of customer feedback role in some of our demos, where I basically try to summarize some of the things that we've been hearing from our customers or that we've run into as tackling network deployments, and try to bring to surface some use cases where we think that our technology could be helpful, eliminating the complexity, inefficiencies that we've seen in the networks today. So the first use case that we want to look at was building the foundation. How we're going to design, install, bring up a network essentially. How we're going to validate that we thought that the survey said, let's put the switch here on this rack, and it actually goes there. Somebody said, we're going to plug this cable into this port, and it actually gets done. This AP needs to be in this location, and it's actually installed there. How are we going to validate that the switch is running the same software, the same software release that we wanted to? The access points, the distribution switches, the DHCP server location. How do we make sure that the right accessories are used, the right cables are used, the cabling health is validated, all before the network is even turned on? How can we make sure that the initial survey data for wired and wireless connectivity translates to a predictive, deterministic installation, right? So Shiv is going to show you how we do that, but I want to highlight one key point in this picture. It's a very simplified picture of a network design, obviously, but traditionally, just to highlight one fundamental problem that usually gets in our way. Usually, when we try to select a distribution switch, we go to our favorite product vendor, and they tell us, hey, I got 5 models and 2 new models from the new generation. These guys run these software releases, but if you want to use the 5th one, we recommend that you use this software release. And the next gen 2 ones, they use this new generation software release that may or may not be managed from the cloud or on premises. So this compromise starts. I select a distribution switch, and I do similar compromises to select my access switch. And then I go and select my APs. And then I realize that the software management, just alone the software maintenance of 3 different hardware components are different. I have different upgrade schedules, different release notes. Sometimes the access point software gets released on June 15th and the switch software gets released on July 12th. And I'm like, okay, how do I stitch these things together? The best practices design guide that I used, that was 6 months old. These new software features, do I have a new best practice design guide? Is the PDF out of date or am I out of date? What am I doing? So things get really hairy even during the design and installation phase. One thing that you will see in Shiv's presentation and other demos is in our entire stack in the Nile Service Block, a very novel idea. The entire stack runs a single software release. Sensors, APs, distribution switch, access switch, the entire thing. The other good news is we don't have patch releases, software branches, etc. All our customers utilize the same software release. Our engineering team does not maintain more than one software release for all our customers across all the sites. Kind of like the Netflix model. There's a canary rollout process. The initial 10% gets tested with the new rollout of the Netflix software. Then if it works well, some bugs are fixed, the remaining 20% get it. Some more bugs are fixed, and then I start rolling out to the rest of the world. And eventually all of us watch the same exact Netflix content running on a single Netflix software release. Imagine that running here. And that fundamentally simplifies a lot of things on its own, but I just wanted to mention that. And with that, I will lead it up to Shiv to tell us more about it.
Thank you, Azir. So folks, what we'll now look at is a full-blown deployment that we do, right, from day -n all the way to day 1 and 2, because this is a service, and we are in the life cycle, till the end of the service. So with that, what it all starts with is a site discovery. So customer signs a PO. All they have to do is tell us where do they want service. They go into the Nile portal. They will say, this is a site, could be San Francisco, could be Bay Area. This is a building, a physical address, and this is a floor and floor plan. They have to do that at bare minimum. Once they do that, even though they don't have any SSIDs or subnets defined for their end users, the Nile service can come up, right? So they do that, and they push it to us in the back end. We have a full-blown system, which I will go into in the next slide, called the Customer Management Portal, right? This is an internal system which our project managers use to manage all the work orders and jobs, right? It's just like anyone showing up at a house to do work with a work order and job. It's very similar to that. So the first job is going to be the site discovery and site survey job. And this is very, very important, right? We've been to closets, coming from product companies, we never cared, right? We just threw the product over the fence, and who installs it, how it goes, no one knows. But it's really tedious. You go there, you don't know what the closet looks like. You don't know if there's enough power. How's the temperature in the closet? Is it a 2-post rack, 4-post rack? Where are the fiber patch panels, right? How do you connect to those? All that stuff is now captured in a site discovery, right? So you can actually go step by step and enter that information.
Who's
Not only that,
performing that? I'm sorry, who's performing that site discovery?
it's going to be one of our partners who will
Okay.
send on site, and they'll work with the customer, obviously, to get access to the MDFs, the IDFs, and they would do it.
All right. So is the kind of when you say a partner, is that like a channel play, or is that you're going to partner directly with companies who literally do physical audits?
So we have both options. If sometimes customers already have their own partners that they prefer, they've been working with them. So that's one option. Second is channel partners who have the capabilities. They're also, can do it. And we also, in case if that's not the case, we have partners who can go and do the actual, feet on the ground, if you want to say.
Thank you. Sorry to interrupt.
Absolutely, no worries. The second part is the wireless site survey, the most important piece, right? AP on a stick, you take that Wi-Fi stand, you go and say, can you hear me now? How well do I hear you? You basically have the entire AP layout, right? Now, this is where the magic happens. All this stuff, once it's entered, it's sent to a cognitive module up into the cloud. And that basically goes and generates everything that is done manually today. Today, how do you create topologies when you do you go to Visio? I guess Visio is dead, maybe draw.io, right? That's where you would go, you start drawing stuff. None of that stuff is required with us. It's all done automatically, a topology. This AS is going to connect to that DS, right? Automated BOM, everything, not just the Nile elements, but the transceiver that goes with it, right? The fiber patch panel that goes with it, the AP mount that is needed, the DAC cables that are needed, right? All that stuff is auto-generated. Third, you have the topology, but topology is still a high-level topology. That AS is actually connecting to a fiber patch panel. That fiber patch panel connects to that building, and that building, you have a patch cable that goes through a distribution switch. That is what the connectivity plan is. So we actually give you step by step, go into this closet, and I'll show you some of that demo in the next slide or so. You would have a connectivity plan. Same thing with the APs. You're going to send a cabling vendor out there. How is he or she going to do cabling? Where is the AP going to be? So we give them a AP cabling plan. This is where the APs are. Go and pull the cable here, pull it to a patch panel into that MDF or that IDF, because there may be 2 IDFs or MDFs on a floor. And from there, you have to patch it to a switch, right? So those are the cable connectivity plans that we have. And then finally, once we have that in place, we create an installation job. So this was a site survey job. There's a cabling job. And now you have a installation job. Installation job is, again, a mobile app. All these documents get pushed in there. It's all within the mobile app. Before you go on site, you will have all the information that's needed, including what you need from a tools perspective. A scissor lift, because you're going to be doing cabling because of high ceilings. All that is captured as part of site discovery. Most importantly, we are humans. We still make errors. I plug the AP into the wrong port. I connect this distribution switch to a different fiber patch panel. All that stuff is detected online as these devices are coming up. Those are called deviations, and all that rolls back again into our customer management portal. Some deviations we'll accept, right? It is too hot in there. We cannot get air conditioning, so we accept that deviation, move on. Some we will not accept, right? This AP has to be in that port, or this DS has to connect to that AS, right? So it's a full life cycle that happens, and it's a continuous thing that'll keep happening even post-installation. If an AP moves, a sensor moves, we have all these soft bots that are monitoring this stuff and automatically generating tickets and alerts, to the concerned parties to go and take care of it. Okay, with that, we will move into the demo. Thank you.
I have a quick question before you get into the demo. You were talking about topology up there. Does this system work on any physical cabling topology? Like, there's differences between an office building environment and an industrial environment, a big warehouse environment. You may have. I've got customers with daisy chain switches instead of the true wired back to an aggregation switch. Do all your features work fine on any physical topology?
Yes, so the way we do it is everything that with the Nile is interconnected directly, right? So we will make sure that if you're coming from closet A to closet B, it's going from a Nile switch to Nile switch. You could jump closets if you want, but all that will be captured as part of the cabling plan. But that connection between an AS and DS has to be within the Nile, because that's the way we can guarantee service, right? We're not having a third-party switch in between that we will jump through.
Right. But so what I'm talking about is like daisy chained Nile switches. That's fine. Okay.
Yes, absolutely.
What's the underlying protocol? Are you using EVPN, VXLAN? What's going on under the covers?
Sure. So first of all, you heard of the fabrics and all sorts of different technologies coming. They all added a lot of complexity, frankly. We simplified that extremely well. It's underlying, it's simply layer 3, OSPF. That's a routing protocol that we're using. So when an AP or a switch is powered up, internally, they go ahead and connect, get the IP address. Nobody needs to configure the IP address. All of the APs, all of the switch, all of the 48 ports on the switches are unnumbered interfaces. They just have a loop back interface. They go ahead and get the IP address locally. And once after that, the protocols come up and discover everything, like the entire fabric, entire Nile Service Block on its own, and then start providing the services. And in terms of the, we talk about the isolation, zero trust isolation. That's where the end users, all the wired and wireless devices, they're already sent. They are sent to what we call NSB gateways. That's where all the, policies are implemented. So there's no, EVLAN or VXLAN. None of this complexity. We eliminated all of that complexity as well.
Okay, thank you, Suresh. So this is our customer management portal. What you see here is the customer name, Nile Demo. That customer created a site called San Francisco, and this is done in the Nile portal, which customer has access to. There's an engineering building, and there's suite 300. That's pretty much what they did, and they upload the flat floor plan. Once they do that, we can now come here and create work orders. So in this case, we already created that work order, which was auto-generated once the customer signed up. When I click on this work order, there are multiple jobs you can see. There's a site survey job, which is all about the site discovery, the physical site survey. We can do Ekahau, we can do Hamina. That data is imported into the customer management portal through the mobile app, and that's where all the churning happens. And then we can do cabling and installation. So let's double click on the site survey. This is what I was talking about. We have our sites, we have buildings. Buildings have multiple floors. There is basically a closet. You can have multiple closets on the floor. You can have multiple racks, and then within a rack you have an asset. An asset could be a fiber patch panel. So think about walking into a closet and seeing what do you see, right? And what we're really worried about or interested about is fiber patch panels, Ethernet ports, right? How many are being used, how many are not being used, so that we can create an accurate BOM. So all that stuff can be captured here. Not only that, We can also tell you, what type of panel is it, LC, SC, ST, because those are very important. You need to have the right cable and the right transceivers. And trust me, right, when we started doing this was all paper and pen. I went for an RFP to one customer site. 14 companies showed up. People have, this thick stack of papers on floor plans, drawing circles or iPad, taking pictures. And that's when we built this app. We said it cannot be that way because you have to pass this on to someone else. I'm not working on it. That gentleman who did it or that lady who did it is going to give it to someone else, right? So everything has to be captured here, including the firewall uplinks, what's available, what's not. So you may not be very technical, but if you can read all those things, that's great. Even with fiber cables, can you read the microns on that and give us that information? You may not know it's OM1 or OS2. So all that stuff is captured here. Once this is done, the Ekao site survey is combined in. The Ekao site survey has tags. You can do mounts and things like that, or ceiling types. We auto-generate the entire BOM. And if I go back into the CMP over here, what you see is a BOM. And this BOM is completely auto-generated based on the data that's coming from the site discovery. So as you can see, it has Nile elements. It's got the fiber cables. It's got transceivers. It's got all sorts of things that are needed to get that entire NSP up and running, not just the physical elements alone.
Question about the BOM generation or even some optics or fiber cable choices, right? Is there kind of a minimum bandwidth? Ethernet technology is changing a lot right now.
Right.
100 gig access could be a thing very soon for
Yes.
many customers, right? So is there a way I could specify if, hey, I want 25 or I want 100? Where's the breaking points in that?
So from an NSB perspective, NSB perspective, right, today with at least with APs, we go 5 gig, right? So we want Cat 6A. That's our golden standard, right? We want OM4, if it's between floors. We want OS2 if it's between buildings, right? Now, obviously, that's not the case everywhere, right? And if that's not the case, then there's a deviation. That deviation is either accepted or, we can work with the customer depending on the requirements, right? But usually we would accept that and move on.
Okay.
Because that's very hard to change. It's fiber building to building, right? Great learnings, especially when you come to a product company and you don't know about these things. It is great to learn. Okay, so that's a BOM. And what we also do is we call something as NPD. NPD is something like a topology. It's called Nile Planned Deployment. This is what we're planning to deploy, right? It's not there in the physical world yet, but this is what we're planning to deploy. And this is talking about every single element, where it is going to go, right? What's its location? What's the NSE type, the Nile service element type? And this was, basically the interconnect we spoke about, right? That this AS connects to this particular AS, or this AP connects to this particular AS. All this stuff is basically then mulled over, and a document is provided, and that's what you see over here. So the Nile cabling plan, auto-generated document. As of now, it gets pushed in the mobile app, and what you see here is, from a cabling perspective, you could leverage this to say where are the APs going. So I know where the APs are now, so I know I can go and install the cable over there. Usually the cabling guy can even patch the APs to the switches. So we tell him, okay, you need to go into that particular closet, and use a flush ceiling type and connect it to AS1, right? NFT AS1 in this example. So we provide them with all the information and even the cable length, because we can kind of calculate that or guesstimate that. They know what they're working with, essentially. The next we provide is a closet interconnectivity plan. This is very important. You're walking into a closet, you have a pallet of devices sitting out there. What do you take to that closet, right? You're kind of scratching your head. And that's where, again, these are all lessons learned, right? The hard way in a way for us. But we first give them, okay, before you get in the closet, please take 2 access switches, take 4 of these SFPs, this fiber, that DAC cable. And once you're in the closet, this is what you're going to do, right? Go to rack 1, go to so-and-so RU, put that switch in there, insert your SFP. From there, take a cable, go to the fiber patch panel, yada, yada, yada. So the intent really here is to give them a step-by-step guide on how this all works. Finally, this all gets pushed out as part of the installation job. And once it's in the installation job, what you can start to see is how are these devices coming up. So in real time, as they get activated and they come online, we will start to see them. Most importantly, we can see the deviations that we spoke about, right? Deviations will happen. We are humans again. You make a mistake in connecting something. Just an example here, AS6, we have 5 deviations. Some are resolved, some are not acceptable, right? Some we might accept. So in this case, we resolved, let's say this one, where you had to add a link between AS6 and AP14 between ports 1 and 48, not port 54, for example. So that's how this all works. And once the deviations is done, this is the whole life cycle that we go through. And then finally, we have we'll talk about some of these other tools that we have where this shows up as a monitoring, with all the content and metrics flowing in 24/7. Awesome. Okay, thank you. I'm going to hand it over to Suresh next.
As you guys are switching, I do have a question. Maybe I just missed it in the conversation.
Sure.
But what is this sensor actually sensing?
So multiple things.
Okay.
You know, when you think of the RF in the ceiling, it's different from the RF on the floor, right? It varies a lot. So it gives you the user perspective, how the user is receiving the network. That is one. And it's monitoring for the wireless IPS IDS. What you see there versus what you see here could be different. And it's also monitoring for RF channels, interference. We have the data in the cloud AP as well as here. And more importantly, it is testing the network 24/7, multiple times a minute, showing that end-to-end networking, not the AP, but all the way to the end of the Nile Service Block. Right? Every switch, every port is being tested and to show that network is up and running. And second is it's also giving the signal strength at that location. And you know, you'll see closed loop automation because you know you put it here today, you deploy the Wi-Fi, and tomorrow things change in the physical space. When things change in the physical space, how would you know that things have changed? These sensors give us the information, which will go into part of the next demo. And using that information, our closed loop automation will come and take care of certain aspects of it. And it's also giving you the coverage and the capacity from the end user perspective.
I was gonna say, so is this actually acting also as like a repeater or something?
No.
No. And then how many of these would you really need? Would you need like one for an AP area? Or?
Sure. So typically what we do is we deploy around the perimeter or critical areas, but at the same time, we also know that not everywhere you can deploy this for many reasons, some right outlets and you know different aspects. So we have a dedicated radio in our access points that acts just like this, except that it's in the ceiling versus being an external device.